before it gets served. So maybe that. But
Let's get this first. I have
if you're gonna sit in the Jabber, I'll sit. We also.
well, let's see if I actually get in. I don't know. Let's see if you see it. You see it?
I don't see you yet.
I have more trouble with Jabber clients. I've tried 2 different clients, and you don't see it. The only person I can talk to is Lou.
What room are you in?
LSR.
And you see Lou?
I don't see anybody.
Oh, yeah. This is the people.
Shoot, and you're just at lsr.jabber.ietf.
There's also we also have this the ether packet, right?
Yeah.
You've been disconnected. Why? Okay. Right. Oh, yeah. Want to get started? Okay, I think we're gonna get started.
Be in the new.
Okay.
Le groupe de LSR.
Okay. Why is it doing that?
I don't know. Oh, this is working.
Okay. So, do we have a Jabber scribe, or is that going to be us? Okay, John's doing it. Usually it's Mika, but he's not here. No, you're it. And we have a. Okay, and we already have that. The blue sheets are being passed around. So here's the note well. So note well. I guess we're supposed to read the bold. So by participating in the IETF, you agree to the following process and policies. You have to make aware of any IPR. You may be recorded. Pictures of you may be taken. And you agree to work respectfully with others. That's the important one. Okay, so agenda bashing. Does anybody have a problem with the agenda? Anybody want to add something? Yeah, it's a little tiny. Not much bigger. Okay. So me and AC haven't agreed upon a common, he wants me to use PowerPoint and I haven't agreed to do that yet. So we have 2 different slide decks for our status. I'll start with the ISIS. So since London, we have 1 new RFC. It was a BIS update, I think. And we've sent 2 documents to the IESG, the reverse metric and the second MSD. And we're ready. UMA's shepherding the segment routing extensions. Apparently, this is he was waiting on one final author to do the IPR clearance. I said that if he should ask all the authors to get a hold of that author, and if not, then we got to move him to the contributor section. But anyway, that's process food that we should have cleared up real soon now. Yeah, and then we have a one in last call. Is that 7810, is that the restart?
So Les Ginsberg, 7810 is not a new RFC.
Yeah.
It's the BIS
BIS,
that
right.
we're trying to
Yeah.
move forward. And I believe we're
The
past,
T,
aren't we past last call now?
Yeah.
Last call was completed.
yeah. Well, I mean, until the button gets pushed, right? It sits in
Okay.
the state.
I'm not quibbling, I would really like to get that
It's
moved.
not waiting on anything in last call anymore. It's completed.
Yeah, I would really like to get that completed as fast as possible because it's just a tiny but important correction.
Yep. Yeah, that one actually showed up in working group status as a new document. So I think we did pretty good on the speed, right? It went from new to last call in one meeting. Okay. So we have some working group documents. We have the LSR Flex algorithm was published since last time. We have an update to our ISIS that'll be talked about later. The blue ones are talked about. Yeah, and then we have the desk source routing, which just was about to expire. There was some concern that no one was going to work on this, right? And so if you care about this, right, I think that you need to get some more talk going on the lists and maybe move it forward a little bit.
I don't see, is David Lamparter in the room?
Right?
I haven't seen him, okay.
Fred Baker would be the other guy. Okay. And then this is just there's no reason to talk about these because these are all the individual documents that are going to be presented. Okay. I think that's it. Oh.
And then the system. Okay, I'm just going to go through these real quickly. How come it's not? Oh, I'm holding it upside down. Okay. Okay, so we have two new RFCs, the OSPF v3 extended LSAs at long last. So all our extensions now should be able to cover both OSPF v2 and v3. We also have the Shadra's, I mean, she's not the only offer, but the OSPF link overload, which also has some identifiers in it for disambiguating parallel links, both numbered and unnumbered. On the, we still have these on the RSCQ. That top one, I don't know about, it's waiting for IDR tunnel and caps. Probably it would have been better just to use our own registry, but it's too late now, I guess. Because it really doesn't share much with IDR except the registry. OSPF segment routing, there's a couple drafts in spring that are close to being, I think they've both gone through working group last call and are going through the discussions. And beer is being edited. That was a VEER document, but it was reviewed. We reviewed it here as well and last called it in this working group. We have these two, the maximum segment def, that's Jeff et al, and link local interface ID link local signaling, that's Peter and others. Both of those we're waiting on Alvaro. I don't think he's here. I think he's still celebrating from the football game yesterday, because he was actually in Russia for the games. These drafts are close. We're going to working group last call the OSPF Yang model shortly after this meeting. We had one last meeting on it. I'll let Ying Zhen talk to it next. OSPF v3 segment routing. I think we're going to have an update today, but I think we're pretty much ready for that. Not an update today. That's wrong. But that is ready to last call as well. And these two are stalled. The first one is stalled. I think we should have, working group last called this one, but we had a breakdown of communication with the offer. Any offers to this one here? I know Alberto's an offer on this one. One of the problem is it contains an implementation specific part in the normative text that I'd like to see removed and have it be reduced to not saying exactly how you use it, because I think it's kind of a very like I said, implementation specific. So hopefully I'll contact the offers and see what they want to do. And then the HBIT support. Are there any offers here? Kair's here, yes. I'm just waiting for them to take my comments prior to working group last call, and then I'll take those comments and submit another version, then we'll working group last call them. Now we will have a couple of active working group, a few active working group documents. We have TE attribute reuse. We're gonna have an update on that today from Peter. SR Yang, again, the priority is the regular Yang model. And this document will probably be able to go forward pretty soon, because the foundation or the draft that it's based on in MPLS is through working group last call and is taking some level of comments. So I'd expect to working group last call this soon. And that's it. Yingzhen, I'll let you do it. Maybe I'll get an E for preference. I can't get me.
Good morning, everyone. My name is Yingzhen. I'm here. This is an update of all the LSR-related young models. So here is the list of people who have been actively contributing to all these models. So I'd like to take this opportunity for to thank them for their contributions, and also thanks for people who have provided us with valuable comments and reviewed the document. So for OSPF young model since last IETF, here is the list of changes we've done since last IETF. And the major work, we have been working on the harmonization of between OSPF and the ISS data model. So for this one, we are really in the stage of finishing it up. And if you want to provide some comments about this one or any feedback, this is your opportunity. We've done addressed all the young doctor review comments, and we are going to have one more revision of this document right after this IETF, and we are going to start the last call process of this one. ISS young model. So this one although this one we haven't started the young doctor review yet, but because of the similarity of this model and the OSPF model, we took all the comments we got from OSPF young doctor review and fixed everything here in the ISS young model. So we also did a lot of editorial changes, clean up the data model. So after this IETF, we'd like to request the young doctor review formally. And then hopefully it will go through quick, and then we do the last call. OSPF and the ISS SR young model. We do have a protocol independent segment routing model that's in Spring Working Group. These are the protocol specific part. Because we do have dependency on the base young model, also we have dependency on the protocol extensions. So this one will progress after those documents published. And that's it. Any questions?
So, I don't know, I haven't really talked to AC about this, but I'd like to progress these together, like, so,
There's only one reason. These documents are so large. I think progressing them together, I'd say consecutively would be a good idea. But if you send them 150 pages of Yang, and then you send them more like 120, and then you send them 240, I think 120 is preferable.
so the reason I want to send them together is because if something is found in one, I'd rather have it fixed in both, right? Like, so we don't publish one and then later publish one that's better.
So Jeff, I was offering a bit of advice from BFD land. We're trying to advance our Yang module. Things get extremely pedantic at the IESG level, and it's better if you actually have one of them go through that process and get those resolved before you actually try to roll it into another document. Otherwise, you're going to get a lot of let's call them unusual comments that it's easier to resolve once and just say, oh, you saw this already, and then move to the next board.
Okay. Take the advice.
Yeah, so although it seems like they're sequentially, but we are really working on them together. So all the young doctor comments that we got from OSPF already addressed in ISS.
Right. I mean, I think my main concern was like the way that BFD didn't get integrated into ISIS until like a whole other meeting happened, right? So I didn't want to see the same extra meeting added to the process. Thanks.
Thank you.
Oh man, I do not have these down. Do you know who's up next? Is it Peter?
Yes, it's Peter. It's 2 or 3.
Three, I think.
3, I guess. Yeah.
Okay.
It's on our side.
Oh boy. New territory here. Is this the one you want to start with? You have a thing there, yeah. I have to make. You know how to work it.
What's this? This is PowerPoint.
Yeah,
Yeah, View is. It's not a Mac though, is it? No.
this is like a,
Present. Try that.
yeah. Okay. Okay.
What's this? A Chromebook or what is this?
Yeah, it's a Chromebook. Fancy new.
All right. So quick update on the link attribute reuse draft. Where is this?
You holding it upside down? Oh, maybe it doesn't work with the PowerPoint? Okay. Yeah, let me get what is it doing? Okay.
All right, so the major change that we introduced in the latest update is that we added the OSPF v3 encodings for this. So we have the OSPF v3 intra-area TE-LSA, which has been defined in the old RFC. Now we have the extended router LSA that has been defined for v3. So basically what we are doing is we are putting the app-specific link attributes inside this extended LSA. We use the registry which has been defined for this to allocate the code points. It's exactly the same approach that we use for OSPF v2. So we have our original TE-LSA, which is used to propagate the attributes for TE, and then we have the other applications for which we use the new extended router LSA. One other change that we did, we changed the name of the TLV because we have extended link LSA, we had extended link TLV, and then we had extended link attribute sub TLV, which has been a little bit of too much of the extended stuff. So we call this an application specific link attributes sub TLV. So we just rename it, and now it's becoming sub TLV of either the OSPF v2 extended link TLV or OSPF v3 router link TLV itself. Next slide, please. The other change is that we made the maximum link bandwidth as an application independent attribute, and we moved it out of this /TLV. Basically, the rationale is that because this is application independent, it doesn't make much sense to advertise it as an application specific attribute and introduce all the or advertise with all the bits set. Instead, we basically say we put it at the top level TLV, saying this is completely independent. So now we can advertise this inside the extended link TLV in OSPF-v2 or in a eRouter LSA router link TLV in OSPF-v3. If we use the same format as has been defined earlier, it's just put it there in these new containers. Next slide, please. We also added the local and remote IPv6 address sub-TLV, so you can advertise these two addresses for other purposes than TE. So we can put it in OSPF-v3, extended router, let's say, router link TLV. Next slide, please. So these has been the changes. I mean, the document has been there for quite some time. We have presented it several times. There has been no major changes. I mean, the OSPF-v3 encodings are changed, but there's nothing, changing what we do. I think it should be ready by next IETF for last call. Any questions? Okay, so this is an update on the Flex Algo draft. So what happened from the last IETF, this has been accepted as a working group document. We also merged the OSPF and ISIS Flex Algo stuff into this single draft. So it covers both OSPF, OSPF-v2, and OSPF-v3. And there has been some early allocations done for OSPF router information, TLV, and also for the ISIS router capability TLV to advertise the Flex Algo definition. Okay, next slide, please. So as I said, now we are covering all three protocols. The other important change has been that originally we defined this to be really only used by SR, but there has been a feedback from the group on the last IETF to make this usable for other applications. So now we basically allow this Flex Algo to be used by any application. But we need to be careful here because the handling of each of the application, how the application is using this, needs to be defined for each of the application independently. What we are defining in this draft is how we are using this Flex Algo inside the SR. For other applications, they have to define this elsewhere. We are not defining it here. There has been a lot of editorial improvement. There's a lot of good comments coming from Eric, Rosen, and Tony. Thanks for that. So we improved this significantly. This has been restructured, so it's much easier to read at the moment. Next slide, please. So we changed some of the names of the fields. The TLV itself didn't change, but we renamed the algorithm field to be a Flex algorithm field. Basically, this is the value from 128 to 255, which basically is a numeric representation of the calculation type, metric type, and a set of constraints. So this is all being encoded as representing these three things in a single value. And the calculation type itself, the algo type has been really renamed to calculation type because this is what we want. And the value comes from the 0 to 127. It's a standardized value from the IGP algorithm types. But we say if the algorithm type defines anything else than the calculation type, we only take the calculation type. Because the algorithm type can specify some other stuff than just the calculation type. So that was the intention originally, but we clarified in the text. There's one other thing which has been missed in the last version is that basically we specify that if the Flex Algo definition has something in it which the router doesn't support, basically the router has to remove the participation from the algorithm because basically it can't compute. So this has been specified in the text. Next slide, please. And we also specified or put more details about the node participation. So what we say is that the participation in the flex algo must be algorithm specific because now we want to use it for different applications. And the reason why we need that, because if certain applications want to use it, it needs to install the forwarding entries. So for segment routing, we are basically advertising the participation based on the segment routing extensions, which has been defined in the IGPSR extensions. It is a topology independent advertisement. So basically it means if I'm participating in a certain algorithm, it applies to all the topologies I participate. For the other applications, again, it needs to be specified for that applications in some other drafts. We are not specifying it here. It can be signaled on a per topology. It can be topology independent. It's up to the application how the application signals the participation. The calculation itself, again, originally we only were talking about how to calculate for segment routing. Here, basically, we say what do we do for the segment routing. Also, the other applications have to specify, how are they going to use and calculate the path. One thing which needs to be considered is what do we do with the nodes which are not participating for segment routing. What we say, the nodes which are not participating in a certain algorithm, they are not going to be used in the computation. The other application may decide to do the same or may decide to do something else. Again, it's up to them to define their behavior. Next slide. And the last thing, obviously the forwarding, we specify that how do we use the segment, the flex algo forwarding in the context of the segment routing, where we use the flex algo specific seeds and use the MPLS forwarding. We specify that if there is no flex algo seed, we don't install any forwarding entry. And if there is no forwarding entry, the traffic which is supposed to be forwarded must be dropped. This is how we want to use it in the context of the SR. The other applications, again, they can specify what they want to do. And if they want to do any kind of a fallback to a default algo, it's up to them. Again, it's not in this draft. So we are waiting for more feedback. We would like to continue to evolve the draft. We have some implementations available, so there is work going on this.
AC Random Cisco Systems. Peter, if somebody couldn't somebody, I mean, it might be unwieldy, a bit like not via, if you remember that. Couldn't you define a separate loopback for each service, and this would work with that if somebody wanted to define all the details, or is that something that would be hard to do?
By loopback, you mean specific address?
Yes.
You can.
Yeah.
You can. Obviously, you can. But the intention here is you don't have to.
Exactly. Right. But that would be one thing that could, if somebody really wanted to do that on base IP.
Sure.
Yes.
Yeah.
And that would be described in a separate draft.
Probably.
Yes. Okay.
Okay, any other questions, feedback?
Speaking as working group chair, I wasn't asking for this draft, but just hypothetical.
Okay, so the next one is the ISIS SRE6 extension for ISIS. So there's a lot of contributors on top of the authors on the draft, so we put the names here. Okay, next slide, please. And there is an OSPF v3 equivalent. It hasn't been updated yet based on what we did in the ISIS, but that's next thing to do. So we have an OSPF v3 document which is going to follow the same thing that we did in ISIS. So the major changes from the last version. So we used to have the node seed TLV. We have removed that and we replaced it with the SRV6, what we call the SRV6 locator TLV. The end seeds are now being advertised as a sub TLV of this SRV6 locator TLV. All the MSD sub TLVs has been, or the seed depths is now, they are being advertised as using the MSD sub TLV, which is defined in the mentioned draft. And we added the support for topologies and algorithms in this version. So this is high level, and then I'm going to go over the details. So in the previous version, I mean, there wasn't any really association with the algorithm for a SID. So basically, if you look at what the SID is just a 128-bit value. It has certain structure and basically locator and a function code. So the locators are the entities that are algorithm and topology specific. So as are the SIDs in the MPLS. Each locator basically is covering all the SIDs which are advertised from the node. And this basically means that the locators are the entities which are installed in the forwarding of the transit routers. The SIDs are not. So basically, the routing entities are the locators. And these locators will be topology and algorithm specific. Next slide, please. So here's an example. You have the zero basic topology, base algorithm. You define the locator, which is a /64, and then you define your SIDs, various functionalities as 128. And then you have another MTID 0 algorithm 128, you do a different locator, and then you define your SIDs. So these SIDs are basically covered by the locators itself. And those locators are advertised and installed in the forwarding. So the SRV6 locator TLV is the TLV that we use to advertise these topology and algorithm specific locators. They are ignored by the legacy routers, obviously. We do install the forwarding entries based on these advertisements, the locators, if the node obviously is supporting SRV6 for that specific topology and algorithm, it has to install the forwarding entry based on these advertisements. The locators, well, could also be, the locators could also be advertised as a prefix reachability inside the prefix reachability TLVs. That means that the legacy routers could actually install them and will use them in the forwarding as well. So basically, this is used for the backward compatibility. Obviously, it is optional. It's up to the user to decide what he wants to do.
ACLN of Cisco systems. So in that case, a router that did support this would ignore that and install the, it would use the other advertisement. I guess it wouldn't matter because it would result in the same forwarding plane for a transit router anyway.
Yes, it will. I mean, the router which understands will see this advertisement coming in the two different TLVs.
Yes.
And we say that we prefer the prefix reachability advertisement from the SRV6 locator advertisement. Okay, so this is well, doesn't show up very nicely on the picture. Well, so this is how it looks like. As you can look at it. I mean, it has the locator itself, its size. It has the algorithm encoded in it. We have flags. There's one flag which we define. It's to indicate that it was leaked because this is something that we can leak between the areas. And there are sub-TLVs, optional. We haven't defined any, but just for the future, we defined a sub-TLV space there. So the NSIT sub, actually we did, the NSIT sub-TLV is a sub-TLV of this. So the NSIT is the equivalent of the node SID or prefix SID in the MPLS, kind of. It inherits the topology and algorithm from the locator advertisements. It is not associated with any neighbor. It must be a subset or subnet of the locator TLV, obviously. Any of these SIDs itself, they are not being put into the forwarding. These are basically leaked together with the top level TLV, and these are some of the SRv6 endpoint functions that are supported. Okay, the next slide. So again, this is the format. So you have the seeds, you have the flags, no flags so far. You have the endpoint function and then the seed itself and plus optional sub-TLVs. So the SRv6 and X seeds, these are the equivalent of the adjacency seeds. So these are advertised inside the existing TLVs as a part of the neighbor reachability advertisement. So 22 and the related TLVs. It inherits the topology from the neighbor advertisement, so we don't need a topology to be there. But the algorithm itself must be specified, so that is part of the advertisement. Obviously, it should fall into or must fall into the locator space, because that is going to be used for forwarding. None of this is going to be installed in the forwarding itself. Again, we are relying on the locators, which are going to cover these. And we have the index and NDX6, as defined in the SRv6 network programming the draft. And we have two versions. One is for point-to-point, another is for LAN. Okay, next slide. So this is how the TLV looks like. Again, there's an algorithm field there, which is an important piece. And then the seed itself, a bunch of flags and sub-TLVs. Okay, can we have the next one? Yes, this is going to be the LAN. Yeah, this is the LAN version of it with the system ID, additional system ID. Next one. So these are one bunch of the flags. These are the same flags that we defined for the adjacency seeds for the SRMPLS. So it's the same thing being copied here. Next slide. And then we have the SRv6 capability sub-TLV, which basically indicates that the node is supporting SRv6. And there are some optional sub-TLVs, but there hasn't been any of these defined. There's one bit, which is the old bit, which indicates the support for the OAM, which is defined in the other draft, which is mentioned there. Okay. Next one. And the last thing, we basically changed the way we advertise various SRv6 maximum segment stuff and for different functionalities. So this has been advertised in a different way. Now we have moved them into what we specify in the segment routing MSD draft. So there are sub-TLVs of the TLV, which is defined there. It gives us the possibility to advertise these not just on a per node basis, but also on a per link basis, which we didn't have before. So that's the major, or that's the advantage of doing it this way, among the others. I guess that's it.
Jidong from Huawei. One question about the NC sub-TLV. Can you go back to the slide? And X seed. And X. Yes.
This one.
I see you added the support for the algorithm in the X seed sub-TLV, right?
Okay, you can go one more up or even here. Yes, the algorithm field.
Yeah, but
Yes.
in the SRMPLS, the algorithm is only applicable to the prefix seed.
Right. But the reason is that because the index seed, it's global here in SRv6. And although the allocator itself contains the algorithm field, right? So you can argue, why do we need it here? The reason why we added it here is just for consistency, because this comes from different TLVs. It may come in a different LSPs. You may change things. You may change the algorithm of the locator. You may configure, you may misconfigure. And suddenly what will happen is that you have certain locator which you want to use for a certain algorithm, but the index seed would actually fall from the forwarding perspective, will be part of a different locator. And we don't want that to happen. We want the strict association. So you basically, by specifying algorithm here, you make sure that you are not going to use the wrong locator during the transition. That's basically the reason.
Okay, so if there's any inconsistency between this sub-TLV and the locator's algorithm,
Yes.
which one will be preferred?
No, basically what you say is if I have a locator which is for a certain algorithm,
Yes.
I make sure that this one will pick that one and not the other one. Because, for example, if you for some reason remove that locator, that this one may fall into a different locator. So you want this set to be algorithm 5, but it will fall back from the forwarding perspective. The best match would be something, the locator which is of algorithm 6. You don't want that to happen. You want to make sure that you pick the right locator. So that's the reason why we have the algorithm field here.
Okay, thank you.
Sure.
So I think I had Les presenting that.
Yeah.
Okay, so you're going to do the, I don't know if you, no, I mean, if you want to do the other presentation,
Okay. You want me to?
yeah?
Yeah, no, it's fine.
Or let's,
Yeah, I mean, I didn't know if you got tired of talking.
No, that's okay.
Have you worked with your BGP collaborators on the same stuff to make sure the changes are in both drafts?
You mean from the BGPLS perspective? Yes.
Okay.
We are working on
Yeah, it's not there.
Okay, so you have it there in the meantime.
I'll add it, yeah, well, we'll keep moving
It's a
on.
dynamic.
Dynamic, yeah, it's Tony Lee dynamic flooding.
yeah.
So let's keep moving to, I think, last year. Yeah, for the Graceful, right? This is probably not going to be a very long one. Here, I'll do the.
Okay, I'm Les Ginsberg. I presented this at last IETF. Not much has changed, so I'll kind of zip through this pretty quickly. Next slide. Does this work?
Yeah.
Oh, great. So what are we trying to do here? One of the things that's missing from RFC 5306, which is the ISS Graceful Restart, is we did not have the ability to signal to our neighbors in advance that we're about to go undergo a restart, which means that the neighbors are not aware, and they therefore can't, if there are other topology changes that occur during the restart, they can't take that into account and understand that the router which is restarting its forwarding plane may no longer be valid. So, where are we here? Okay, I've covered that. So we added 2 more bits into the TLV so that we can indicate that a restart is planned and so that the neighbor can acknowledge that, so that the router which is about to undergo restart can delay a little bit and understand that its neighbors are now ready, prepared for the router to go ahead and restart. What does the neighbor do when he receives the planned restart? He just marks the adjacency state as being in restart. He updates the hold time based upon what's been sent to him, and he sends an acknowledgement. And then this state will get cleared when the actual restart occurs, and he receives a hello with the restart request as normal. This allows, again, the neighbor, if there are topology changes that occur during the period of the restart, the neighbors can take that into account and understand, even though they've been maintaining the adjacency in the upstate, maybe it's no longer safe to do so. So the only change that's been made since V0 is there was a suggestion from Uma, I believe, that we summarize the changes. So we've done that in the appendix. And what I'd like to do now at this point, there's been no objections to this draft since the last IETF. So I'd like to go ahead with a working group adoption call. Questions?
Does any, okay, so let's see. Does anybody object to working group adoption of this? No. And do people support it? Raise your hands. Yes, see some hands. There we go. Okay, we'll go to the desk on the list, but that's good. Okay. Also, I've been peeking into the Jabber room, and there's a common comment which is no slide numbers. So it's helpful if presentations have slide numbers, I guess.
Okay, never heard that comment before.
Now you have. All right. So is naming doing it? Ah, there it is. Hmm. Hi, good morning. I'm Naimin Shen in the Cisco Systems, and I have presented this before in Singapore IETF, and this is just a brief update. So basically, this proposal is to support a large number of entries in the full routing in the DC fabric, and mainly it started with trying to support the overlay routing with this ISAS as an underlay. And we support the auto tier discovery, and this is for the zero touch ZTP. And the main purpose of the proposal obviously is to minimize the flooding information. Wasn't me.
I know.
He's helping.
Actually.
Yeah, to minimize the flooding during the link down and node down those negative events in the network.
I see it.
And this proposal works with the other mechanisms such as the open fabric or the dynamic flooding proposal recently introduced. So for the last year, those are the main changes. We added the tier information, so if somebody wants to do the auto discovery and without explicit provisioning, and as long as the tier 0 is known, and this can be discovered dynamically. And in the most recent revision, we added a bit in the link attribute of the iSize sub-TRV 19 of the TRV 22 to say out of this link, my connection is a leave node. So if you are doing a dynamic flooding and algorithm, you don't even need to consider those leave nodes. So it reduces the scaling of the algorithm and make it simpler for the network. And lastly, there are some comments on the question on, the info request sub-TLV is asked for specific information during link or node down. But how do you ask for withdraw those information when the link comes back? So this is just following the normal iSize LSP mechanism. So there's no new signaling is needed. So we added some more text in the draft to explain this portion. And obviously request for further review and comments. And I at least know of one implementation is underway based on this proposal. And the authors would like to
requests working group adopts? Questions?
Well, we'll ask the working group, yeah.
Yeah.
So we have a lot of flooding optimizations, and Chris and I have been having discussions on that. And so we're gonna ask the working group for input as to how to move forward, and as far as people that want to deploy them. I'll be honest, we don't completely agree on the various tracks, but so we'd like to get a lot of working group input on this. You want to add about the requirements?
No, well, yeah, I mean, I don't think we're too disagreement. I just, we've got a lot of different solutions to sort of a common problem. And I'm just wondering, do we just, is it just pick everybody's favorite solution, let the market decide? Yeah, I don't know, but I would like maybe some input from the group on how we think the best way to move forward is with all of these different ideas.
Jeff has I'm not following this work very well, so not that it's not clear, I just don't pay attention to the LSR group heavily. One of my observations here is that this seems to be pitched for a standard Clo fabric type topology, which is very popular right now. But one of the things we've seen in the presentations, including like the open fabric presentation, is that other topologies are being explored for things. My question / comment to you all is this is optimized for that situation. If you end up with a different topology other than Clo, how does this feature potentially interact with those? So as you consider new extensions, consider how it might actually interact if you try to deploy a different topology.
Actually, this is just AC Linda. This is just an observation. I think this one is simpler, that it's just between tier 0 and tier 1. So it's not really limited to Clo.
Right, and that's going to be probably the single most common thing when you look at the other topologies. Is when you get an extra layer or two up that it becomes more interesting. But my suspicion, based on how this is seems to be presented, is that the generalization of here's how it applies for the next level. So you're actually doing auto provisioning for topologies. You have basically the easy mode for Clo, and therefore you're going to have this is your 1, 1, 2. And that they auto-discover each other and can tell that they're miswired, for example.
I guess, yeah, for the zero-touch provisioning, it is targeted at Clo, right?
And Chris Martin, Arista. I was just going to say that if you look at the agenda, we still have, I think, 2 or 3 more presentations that cover areas like this, and that doesn't include what's happening, for example, in Rift. So going back to your point, AC, and both Chris and AC, in terms of how the market looks at this, I would say that there's really from my view, and just I think Jeff just mentioned this as well, there are at least 4 different approaches that are really tied to Clo, and then there's maybe 1 or 2 that are in terms of generic topology. So maybe we look at them as they apply to the bigger use case, which is leaf spine or Clo, and then the generic use case, which is arbitrary topologies, and then let's decide there, because there obviously is a big need for addressing this problem. And I just going back, having these discussions over the past couple of years, we're trying to solve a flooding problem that's kind of limited link state protocols being used in leaf spine or in Clo topologies. If that's what we're trying to do, then that should be the fundamental requirement. A lot of the work that's coming out now over the past 5 years has been to try to fix the flooding problem. So we have BGP being used to fix flooding, when now it looks like everybody said, well, maybe we should just fix the flooding problem. So if that's the fundamental requirement, I don't know if, Chris, this is what you're suggesting, that we go to a requirements document first to try to solve flooding problems in IGPs. Dave Katz did a presentation at NANOG in 2000, and it was this comparative anatomy presentation. And basically there's a slide that literally says, the problem with scale is reduces really to flooding. This is almost 20 years ago, and there's been no attempt made. So if that's really what we're trying to do, then why don't we just focus on that?
Yeah, so that's all really good. I don't know whether we go to a document or not, or if it's enough to just talk on the list, but I think especially when you get competing solutions, if the focus is to try to pick one, then sometimes a requirements document helps focus that. But I don't know if we're there yet. I don't know.
So Russ White, LinkedIn. So my take on this is I'm much preferential to having unified signaling rather than a unified solution at this moment, because there are different scales and different kinds of topologies, like Chris said, and AC has said that, we need to look at, and that I would just prefer for the moment just to go down the path of having unified signaling, and let's worry about the which solution is best depending on what happens in the marketplace and where things go in the future. Because I'm not convinced that a requirements document, the requirement is pretty simple. And I'm not certain that a requirements document is going to be able to capture like operational realities in a way that's going to be helpful in the long term. Just a thought.
Justin Sura, North Networks. So a few IETFs ago, we started routing in BC effort, if you remember. And as a result, we've got 2 new working groups, Rift and the other guy. So I don't think the end goal is to reduce flooding. End goal is to be able to address topology of particular size. And this is what should be. So there was a document requirement for DC routing, and number 1 or number 2 requirement was really ability to address large topologies without hacking around. So I don't think we should be focusing on reducing flooding. We should be focusing on addressing particular topologies, particular size, and see how existing new protocol fit into this picture.
Hi, this is Dino. I haven't been following this work, but for leaf spine topologies, which will be a huge market in enterprise, if you want to solve a lot of people have been talking to me about this, and I said, I thought Dave Katz solved this with mesh groups a long time ago, which was referenced. But if you want to fix the flooding problem in simple, even though large scale leaf spine topologies, just use static routing. Have you considered using static routing?
Yeah.
Say again? Oh. Has the group considered using static routing for leaf spine topologies?
I've thought it, but I think you're the first person to say it, Mike.
I think a lot.
ECP and static routing will take you a long way, right?
Right. Yeah. A lot of these dynamic controller-based solutions basically do static routing. It's just more dynamic than in the past.
Yeah, that's what Jeff's just said, right? Use Yang to just netmod.
AC, it's kind of funny you brought that up, because what does an SDN controller do? It's a management plane that configures static routes, right? We did this in the 90s with IP route commands using, what was the name of that? Rancid was the script kitty, right?
But this proposal is very similar to static routing. You actually install 2 static routes or n static routes. Yeah.
Tony P. Juniper, so links do fail. So as Matt observed,
you withdraw the route when the link fails.
Yeah, that's right. That load doesn't kill the proposal.
Okay.
16 ECMPs in one fail, you have 15 to choose from.
You guys.
Sure.
I'm not sure in session.
But yeah, we
Maybe talk about Mike if you're going to talk.
All right, so as Matt observation, I think the problem neatly splits along whether you have a direct topology, right, a north-south sense, or whether you have a generic topology. And if you work on that stuff, I think you have to keep it apart. I think the north-south, the direct topology is actually quite tractable, and there's a couple of different proposals, different properties. The generic problem has been walked for 20 years, right, with by multiple people with poor results, and I do not think that the results will improve, because nothing new in graph theory, and the properties you will find, the hot links and so on, are still in place. Whether the north-south is more immediate, and I think it's much more tractable. So that's kind of meta input.
Yeah, agreed. That fits more into like the first tier fully mesh, that kind of a scenario.
Okay, well, that was useful.
Yeah. Let's start a thread on this on the list. In any case, we're not going to commit to asking for adoption to any of these today.
Right. I think that was also the point of bringing it up. Okay, thank you. Okay, let's switch back to the Lee dynamic flooding. I don't know who wants to present that, Peter maybe, or I think we got that loaded now. Oh, yeah.
Why isn't this
I don't know.
different?
It's almost like when you're trying to set a conference up, right?
And
Here, I got that.
it does things without.
There's a meeting minutes here.
Yeah.
I think we also have them here.
Obviously, the Chromebook was targeted at a different generation.
Yeah.
Older or younger?
I think that's obvious.
Okay. So, yeah, it's not too speedy. Did you move it up? Here. Oh, good. All right.
Okay, so this is an update on the dynamic flooding draft.
This should work for you now.
Okay, so the major changes that basically there are two major changes. First, we have the encodings for all the three protocols now. It was originally defined just for ISIS. And the other thing is that originally this was defined to work only in the centralized mode. We also introduced a new mode, which is a distributed one, because we thought maybe some people would like to do it that way. So the concept of the area leader, when it was defined originally, it was the one who basically computes the flooding topology. So those who are not familiar with this, basically this is one of those drafts that try to solve the flooding problem. And the way we are trying to solve this flooding problem is to reduce or calculate the flooding topology on top of the existing topology and only flood over those flooding topologies. So originally this was defined to work in a centralized mode where an area leader computed the topology, flooded the flooding topology, and then everybody would flood based on what this area leader calculated and announced. Now we introduced the distributed mode where basically we leave everybody to compute the flooding topology using some algorithm which we agree on, and basically it removes the requirement for the flooding of the flooding topology itself. So the area leader now has in a centralized mode, he is the one responsible for calculating and propagating the flooding topology. In a distributed mode, it only advertises what is the algorithm which is going to be used by everybody else to compute it. Obviously, we only need a single area leader in the area. There's no need for everybody to participate in the area leader election. We obviously would become a few more routers to do so for the redundancy. So as I said, in the centralized mode, it's the area leader who does the calculation and distribution. In a distributed mode, it's all the participating routers who calculate the flooding topology itself. Obviously, we need them to agree on something, and that is being advertised by the area leader. We can either use a standardized algorithm, which would tell us how to calculate this, because we need all the routers to do the same calculation, obviously, to have the consistency in the flooding. It is also possible to use the private algorithms, but we need to obviously make sure that everybody else agrees on what that private algorithm is. So there has been a change in the area leader sub-TLV where we added the algorithm. If it is 0, then we assume that this is a centralized mode. And then we added a space for the standardized algorithm and a space for private algorithms. The area system added sub-TLV, we removed the ending index because it was redundant. We have the TLV length. We can calculate what is the last index in the TLV. And there has been quite a lot of editorial changes. So what is the flooding behavior? If we receive an update on the link which is part of the flooding topology, we flood it on all the remaining links in the flooding topology. if we receive an update on a link which is not part of the flooding topology, we flood it over all of the links in the flooding topology. And when there is a change in the flooding topology itself, for a short amount of time, we need to flood over the union of both of these, new one and old one, just to make sure that, you know, everybody else converges to the new flooding topology. And we added the OSPF extension for this, so we have area leader sub TLV, which is part of the routing information LSA, which is both V2, V3. We have the dynamic flooding opaque LSA being defined for this to be used by V2, OSPF V3 dynamic flooding LSA to be used by OSPF V3. Both of these are only required in the centralized mode. They are not needed in the distributed mode. And then we have the equivalent of the existing ISIS sub TLVs used to announce the flooding topology itself. So I guess I'm not going to even ask for the working group adoption, but we would like to continue to evolve this draft. We need to define some standardized algorithm how to compute the flooding topology, and if you guys have any good ideas, you're more than welcome. And we would like to start to work on the implementation of this.
I have one comment. So is there an implementation that anybody talk about that is underway with this? Anybody? Yeah, okay.
We are looking at that too.
Yeah, okay. So for both the last two of these flooding reductions, there are at least people looking at implementations.
So again, this is a generic solution. It's not tied to any specific topology. It can be used in any arbitrary topology.
This is a naive comment I haven't really thought about, but doesn't like a PIM or, I mean, doesn't multicast distribution give you sort of a tree? Would that be an algorithm?
But it's not reliable.
Well, you
tree.
may have, you want to have some more here, right? I mean, you can come up with the very simple spanning tree, right? That would give you, but you want more.
Yeah.
You want at least a biconnected topology, maybe even some more redundancy. So any failure would not basically leave anyone without the data.
Yeah.
So it's a bit more interesting problem to solve.
Yeah. Thanks.
Okay, thanks.
You got to get out of that mode.
Yeah.
And then this is our materials. And I usually hit control to make it open.
Okay. So.
But we're kind of cruising along here.
Yeah. This one is.
So Uma, you're
Uma?
Doesn't even have a chair. Where did it go? So that. Here. There's your.
This one forward?
Yep.
Hello, everybody. My name is Uma. I'm going to talk about preferred path routing. Last IETF, I talked about this concept, but thanks to Russ, Jeff, and Luis has given a lot of feedback. So we are updating with this title. Next slide. Oh, sorry. Okay. So let's look at a simple scenario just before going to the problems. Simple SR network here. A1 to A7 is the shortest path. It's in blue line. And it's an MPLS network, SR MPLS network. Global indices, SID indices are shown for each node and adjacency. If you have an SR path from A2, A8, B2, B2X, A9, A10, AX, A7, shown in the purple line, it uses both node SID and adjacency SIDs. It's a total 8 SID stack. So this number can go up based on the MSD capabilities. You have all kind of nodes. It can be there in deployments, right from Broadcom chips to high-end chips, Juniper, Huawei, Cisco, whatever. So various MSD, RLD capabilities, you need to insert ELI, EL pair at the appropriate transport stack. So the stack size, the SID depth can go higher. And if you use IPv6, you have to use IPv6 and cap header. RFC 8200 basically, and you have to use SRH header with all 8 seats with IPv6 addresses, basically 16 IPv6, 16 IPv6 addresses. So what's the deal with this? We have a couple of issues with this. In the deployments, legacy deployments, we have hardware capabilities, various nodes can support, various seed depths. So we have a solution for this, MSD, maximum seed depth capability. So with that, PCA can compute alternate paths based on the constraint of MSD, but it may so that you may not have the paths available. So that's number one. And second one is line rate issues. We have tests run on the at IPv6 SRv6 header with multiple seats. It's a huge, significant performance down, line rate down. Jeff has some data on that with various chips. So that's one. Second issue. Third issue is empty issue. With high-end packets close to 1500, we have, if you add a bunch of seats with IPv6 SRH header, we have MTU and fragmentation issues. This is a serious issue. Once fragmentation issue, we have to empty issue. You need to change the network nodes. A couple of configurations need to be changed. It's a serious issue. And apart from that, we have 5G header tags. There are some of the 5G slices like MIOT URLs is defined by small packets. Packet sizes ranges from 40 to 100 bytes. And this is also common in fixed scenarios where interactive and online gaming kind of things where short packets are prevalent. With this 40 to 100 bytes packet, you have to introduce 200 to 300 bytes of network tags. So it's a huge tax. As Russ said, it's an acceptable usage of bandwidth. So what's the solution? We are introducing a TLV which describes the path. So routing happens based on the path. You have 4 components here. We have reachability TLV. We have that prefix. For example, 135, 235, 237, 235, all empty capable ISS TLVs. Whatever is reachable TLV, put the prefix there. Put a PPR ID, that's PPR, that identifier. If you have MPLS data plane, it's a node SID or global adjacency SID or whatever. If it is IPv6 data plane, it's IPv6 address. If it is v4 data plane, it's a v4 address. And bunch of TLVs which describes the path. That is path description element. And third, last one is PPR attributes, which specifies the attributes. For example, for traffic monitoring, traffic usage cases, you can just specify that these traffic parameters need to be accounted for this path. This can be described with PPR attributes. There are some other TE parameters that can be added later. So how do we do computation? Simple example here. R1 to R4 in the purple line, this is a strict PPR. That means all nodes and adjacencies are listed with this. Let's say, for example, on the R9, if when the TLV is received, to reach to the SPF, once SPF computation is done, to reach to R4, the next hop is R11. So because it's shortest path. So, but based on the PDE list, PDE says path description says the next element is R10. So the next hop is changed to R10. So for your SPT computation, your Dijkstra's, nothing need to change. During the round download, just dip into the pen tree, get your next PD element and change the next hop. That's all you need to do. And same thing happens upstream all the nodes. And for the loose PPR, that means all the nodes and adjacencies are not listed. For example, in the yellow lane, R1 to R4, R6 to R7 is not listed. It takes the shortest path based on the Dijkstra's. So for that, but various data planes require various capabilities for this, also described in the draft. You need 2 labels here. In summary, it's a simple change. From next hop, from the actual next hop, SPT next hop to the next hop as described in the PDE list. That's all you need to do. And you have to, of course, you need to program the data plane with the corresponding data plane with the next hop computed. So with this, all FRR solutions, your IP, LFA, MRTs, RLFA, TLF, whatever is there today, computed LFAs can be directly used. You just have to take the next hop, the computed new next hop's LFAs, local productions, it can be applied. But there is also a lot more can be done with this. That will be discussed later. So what is the relation to binding seats? Some people ask, there's no relation to binding seats. It's earlier SR extensions of this advertisement of VROs are there. And with binding seats, as of today, it talks about Advertising, it's a mapping server functionality here. So apart from that, traffic accounting, there are multiple solutions for traffic accounting in IETF right now. So which introduces, because of one of the problem with the SRMPLS is when you keep on going from one segment to another segment, label will be popped. So you don't have a notion of path into the packet. So with this, there are problems in the sense like, how do you account for how many packets are pushed onto each node and the intermediate nodes? So there are solutions where path labels are introduced. The problem with path labels is you need to put a special label followed by path label. So it's already, you have a SIGDUCT issue, you increased more labels to the issue. So one of the solutions talked about is, why don't you compute at the ingress nodes? You can do that, but what happens is if you do FRR, any link or node failure happens, those statistics will be off. So what we are saying here is in the path attributes, you can advertise what are the path statistics need to be counted. Those can be stored into the node, and those can be pulled through gRPC or whatever, Kafka, whatever that can be used. So the original example, the same 8 sets with entropy labels at the right RLD6 here. So you have to put the entropy label at the right spot, ELIL label. So with this, around 12 labels, transport labels. Though service label is only one here, it can be more. We have VPN prefix label, we have VPN egress speed engineering labels, you have for egress node protection, it could be in any case like 2 to 3 labels, service labels will be there. So we're talking about around 15 labels here. So we are with this solution talks about only transport label optimization. With transport label, you have prefix, shortest path set, that is the node set. You have the PPR ID, another node set, and you describe the path of this nodes, and this gets compressed to one label. Same with SRv6, the advantage with SRv6 is huge here. So with the 8 SRv6 in the SRH, it's a serious problem, so it can be reduced to 1. The remaining places you can use, the remaining sets you can be used for other programming or whatever VPN labels you can be used for VPN sets. So the transports is reduced to 1 here. So the Yang data model is described in this document for PPR. There are a couple of questions Cengiz asked last time. What about scalability? Yes, there are n nodes, n square paths, total paths, and with k multiple of each node. Yeah, so but not all paths need to be preferred paths. Only small set of paths are preferred paths. We have dimensioned the network with 200 nodes, 500 nodes, 1000 nodes, and 2000 nodes with 15% capability from edge nodes to paths. So the sRGB for MPLS case, where a lot of customers asked, what is the sRGB usage? So around 15% extra labels are needed for sRGB. It's not a big deal, but separate solution, we are drafting a separate solution to scale this with a tree structure. The tree is rooted at the destination and multiple input points can be there. So this is a separate work where pure scaling has to be done. This will be published soon. Torles is working on this, so we'll come back to this soon actually. So, but for as it is, this draft independently sustained. So where for DetNet and 5G use cases, only from eNode B to UPF, only 3 slices will be there. So the total paths will be less than 500 based on the network though. So with the tree structure, anyway, the n square problem, it's come to a linear issue, k star n, order of n. So it's a linear scale. And another advantage of this is you have path steering support for native IP data planes. This is very important for legacy networks and 5G especially, where SRv6 forces to upgrade all the boxes because it's a new header, new hop-by-hop extension header. So path steering can be done with PPR ID, IPv4 and IPv6 data planes. So there's some work going on. Do you remember, Dino knows this. CT4 response is being framed from 3GPP working group. They are looking for optimized data plane on the new N9 interface on 3G from 2 UPFs. So there are competing solutions there, SR IPv6. There are competing capabilities, Lisp and ILA. So this solution can help in fully compatible with SRv6. It only helps reduce the transport stack, which is the important criteria there. One of the criteria is there. Lisp also, it can help traffic engineering inside the domain, but Lisp has another capabilities what 5G cannot solve. It can offer session survival mobility and other cases, which is orthogonal to this. I'm going to talk about how this helps in 5G architecture tomorrow in the DMA working group. Please welcome there, and if you have questions, you can ask. The concept is presented of IETF 101. We have a lot of feedback. Thanks to us, it completely reshaped the document. And more comments, welcome more comments, and we request working group action.
I have one question. I read the last one. I didn't get through all this one. So the selection of the preferred paths is going to be separate work, right? How you know which subset of those n squared paths you're going to actually do preferred paths for. That is
orthogonal to the stuff that is the PCE complete set.
Yes.
Based on the
Okay.
So,
and this really just covers the data plane and the advertisement of the ingress nodes for the preferred paths. Exactly. Okay.
Hi, Ketan Talaudikar, Cisco. So isn't this very similar to basically flooding an LSP in IGPs, right? Very similar to how RSVPT paths were set up. The only difference that I see is that it's flooded all across the domain. So everybody gets all the LSPs and they just pick where the LSP on which they are part of and program their PPR ID or label. Right? So it's really flooding all whatever order n square LSPs all across the domain to every router.
no, it's not order n square.
I mean,
the total paths.
Yeah, all paths. So let's say
if we have no issue with SR path, please go ahead. You don't have to advertise. If you have an issue, please advertise and reduce your stack size. Otherwise, you don't have to advertise.
Okay, but let's say we have 1,000 such thing in an area, then those 1,000 would be advertised by each of the ingress node, and they would be flooded to all the routers.
Correct.
So it's really an RSVP signal LSP, which has to be programmed hop by hop or loosely, and it's being flooded via IGP.
In RSVP, you don't flood it. There's no.
RSVP signals only on those hops, but in this case, we are flooding it.
Let's take this discussion to the list. And Dino will be the last comment.
This is Dino. So I have 4 very quick comments. First one is I'm overwhelmed by complexity. Number 2, your tax overhead was completely understated. Number 3, I think you found you have to build new machinery to reinvent MPLS in a more complicated way. This is just my opinion. You could take it or leave it, doesn't matter. But you could have solved this problem with straight source routing with not every hop by hop as the SID. You just could have found a repair path and put one entry in the source route to get around the failure, and that would have taken you a long way.
This is not only for FRR. FRR is a side product of it. If you want to do
Oh,
FRR,
so more is coming. Thank you.
No, this is for TE as well.
Yeah, he said there's more to come and there's a lot more stuff and the basic stuff is already complicated. So,
there's no complication.
I'm not looking forward to the sequel.
No.
Well, I'll take it to the left.
Yeah, obviously we could be more talking to do. Okay.
Do you want to start the discussion on this, Uma? On this document, on the list?
Yes, please. We are ready actually for.
So Dino, maybe you can watch for it. Okay.
Okay, I think it's Jay.
We're doing. Do you want to? I got it. Okay. This one?
Yep.
It's hard to tell.
Okay. Good morning, everyone. I'm Jiedong from Huawei, and I'm going to give an introduction about the IGP extensions for the segment routing-based enhanced VPN.
Hang on. It's hard to tell which one is full screen and not. There.
Okay. So here's some background. The enhanced VPN framework is defined in this draft, which is to meet the requirements of network slicing and other similar scenarios. This draft describes the architecture and the candidate technologies for the resource isolation and the integration. This draft will be presented on Wednesday, the TIS session. And we have another draft, which is a segment routing-based enhanced VPN solution, as defined in this draft, which is basically to extend the segment routing to identify the partitioned network resources and create the resource-isolated virtual networks. And because this time we didn't get a time slot in the spring, so please read the draft and comment on the main list. And now we need the IGP extensions for this SR-based solution, and this work belongs to this IRSR working group. Basically, we need the mechanism to distribute the network slice information to both the controller and the networking nodes. So currently, in this current draft, the design is to try to reuse the existing multi-topology routing with segment routing with some necessary extensions. So we expect this mechanism will be applicable to both the SRM pairs and SRv6.
Is it not working?
Okay. Okay. So this diagram shows how we want to extend the segment routing for the resource identification. And we can see on each link and node in this topology, a different dedicated adjacency seed or the node seed are used to represent the partitioned resource. And each seed will be associated with a virtual network, which can be seen as a network slice. And we can use different groups of seeds to construct the resource-isolated virtual networks. As shown in the right side, we have 3 virtual networks, each with different group of seeds. And these seeds can be mapped to the data plane resources isolated from each other. Okay, so here's the overall mechanism. I will not go through the details. So basically, this is a controller-based mechanism. We use the controller to maintain the network states and receive the service request. The controller will do the computation of the logical topology and the resources needed. Then we need the network nodes to allocate the resources and also the associated adjacency and node seed for the logical topology. And then we will need the IGP for the distribution of the mapping between the seed, resource, and the logical topology. And this information will be used by the ingress and network nodes to build the same routing forwarding entries for each virtual topology. And since we want to reuse existing mechanisms, we will take a look at the existing technologies we have. First, the multi-topology routing. It was designed to create multiple logical topologies in the same infrastructure. So far, it has limited use cases, mainly for the creating topology for IPv4, IPv6, or for the different topology for the unicast or multicast. And there's some limitation in the data plane forwarding with multi-topology. It does not fully support the sharing of the link or IP address between the different topologies. Then now we have the segment routing. We can see how it works with multi-topology routing. As we know, the multi-topology routing is already supported in the IGP extensions for the segment routing MPLS. So it allows for the distribution of the topology-specific adjacency seed and node seed, so that we can have multiple topologies enabled with the same interface or IP address. We can use different adjacent seed or node seeds as a discriminator for different topologies on this same link or node. But the problem is, so far we didn't have the mechanism with MTR or segment routing to support the resource isolation or the identification. As I said before, this extension we need to do with segment routing, and we need the IGP extensions for this also. So here is a proposed mechanism. Basically, we will try to use the multi-topology with segment routing, with resource identification. Then we can have each node or interface participate in multiple logical topologies, and the resources on these nodes and links can be partitioned and allocated to each topology. Then we have the adjacent seed and node seed to represent the partitions of resources allocated for each particular topology. These seeds will be used to constrain the traffic to the allocated resource in the data plane. Then we use IGP to advertise mapping between the seed and resource in each topology. And with this mechanism, we can support both the strict and the loose path SR forwarding with topology constraints. Although we can reuse the existing mechanism, we are proposing some extensions which we see necessary. The first is we need to define a new sub-TLV called segment routing bandwidth sub-TLV. It is used to describe the link bandwidth associated with a particular adjacency seed for the use in a particular topology. And the second point is we need some topology support for SRv6. So in this document, we propose a new ID sub-TLV under the SRv6 no-seed TLV defined in the ISS extensions. And then we notice that the newly updated ISS SRv6 extension draft also introduced the support of the multi-topology with SRv6. So we think we can converge on this point. So the next step is we want to solicit feedback on the proposed ISS extensions. And the next step, we also want to extend this to the OSPF. Okay.
So it's Peter Pshenak from Cisco. So obviously MTR exists, you can use it, you can create whatever you can do, a lot of stuff with it. My comment would be, how scalable this is, given that in MTR you have to advertise every link, every properties of the link, adjacency, prefix, everything on an MTR basis. So how scalable this is? I don't know how many slices you are thinking of. And from the provisioning perspective, it's the same thing, right? You have to provision it on a per link basis. So I think there are maybe alternative solutions that you can do the same thing or achieve the same thing in a better way.
Yeah, I think we can discuss offline about the alternatives. And we think the scalability of MTR really depends on the number of topology or slices you want, right? And also maybe you can see whether some optimization is possible.
Hi, this is Dino. AC and Chris, I have a general statement. It's not relative to your presentation, but I see a pattern happening every 5 years that IGPs, especially link state IGPs, are being used to move information across the network. And so you put them in LSPs and they're stored in the middle of the network that don't use it. So you're using all the resources of the middle of the network where really the edges need it and the IGPs just used as some sort of transport. So, I mean, we saw this with IBGP a long time ago and put in route reflectors. And what we saw time and time again is you need a reliable multicast messaging protocol that works among the edges. And expensive routers in the core storing stuff that's only used on the edges is not a good architectural principle. So all I'm making just a general statement is that, maybe this group should look at running reliable multicast protocols on the edge to help transport stuff so routing works better. I know this is a link state routing working group, but you only can do routing so many different ways. And now with the advent of segment routing that came the last couple of years, now people are saying, okay, let's go look at source routing techniques or SDN controller techniques versus distributed in the network techniques, which we all know and love. So the problem is there's only so many ways to do these sorts of things, and now people are just taking every combination of everything, and it's not helpful. It's just creating complexity, and we're not solving any really new problems. Sorry to take up your time, but I just thought I wanted to generalize the problem to other things that I've seen as well.
Actually, we have more time than I thought. I was thinking back to the 9 to 11:30 as opposed to the 9:30 to 12. So I heard, my apologies for hurrying the last presentation along.
So Dino, I sort of agree with what you're saying, that we do need, we've known for the last 20 years that we needed a general purpose data distribution protocol in the routing space. But with real problems, you do have to move on, and the ISIS seems to be a good platform to move this on in the short term. But in the long term, then we do need to work on a better data distribution protocol, yes. So I think we should separate the two problems.
Well, just to clarify, Dino actually was saying that it's a question of not wanting to store stuff in the center of the network, right? Like a lot of times you're just trying to push information to the edge, And if you're putting it in LSPs, it's costs a lot on the internal routers in your network to store that state, because those are expensive.
And you have no flexibility because you have to change the middle of the network to get
You got
X
it, Mike.
functionality.
Mike.
You have no flexibility because you have to change the middle of the network to get edge functionality, you know?
But in this particular case, we're dealing with in-network resources that everyone has to know about. Because this is not about just... I know.
The one example was a mapping function here. There was example of putting services in the network. There, with respect to doing traffic engineering and fast reroute, you're absolutely right. That's for the inside of the network.
Traffic engineering and slicing are sort of kind of very close friends. So we do have to be able to do traffic engineering in here. And so we have to be able to steer the traffic to particular NPU instances, for example, and specific queues. So we are dealing with a lot of detail in the middle of the network that we have to advertise the bindings
For this specific
For this
proposal.
particular application, yes.
AC Lincoln, that was, I mean, I maybe just glancing over this, I mean, I read the draft and everything, but I thought for this particular, because you're doing resource reservation, this would not be a case of only the edges needing to know. I mean, there are cases like you're talking about, Dino, but I was thinking you would need this state.
Yes, I mean, we are going to have to introduce more state to make this version variant of SR work, whatever way we go about doing it. You're going to, it's all about particular resources being allocated to a particular slice.
So we had this presentation routing a number of times, right? And Jeff North Networks. So I would say we need to build more hierarchical structure. It's very flat, so you flood everything to everybody. The capabilities and semantics of your links and reservations, they're property of a node. So if you build more hierarchical structure where you have node and other attributes inside that no business to any other node in the network, you might scale much better.
Isn't this what IDR is for?
And we're more than willing to talk to anyone who's got any ideas as to how we can solve this problem in a better way.
Okay, I think the good news here is the base network slicing should advance before this, correct? Like the SR for networks for enhanced VPN.
Yeah.
Yeah.
The drafts.
Yes. So when keep us surprised as to if that's adopted, we can. I'd still advise people to read this draft, but I think it's contingent on the base draft being accepted in spring. Correct?
I think so.
Okay. Yeah.
Okay. Thanks. Yeah, you can. Yeah, you can do that. Yeah. This one?
Yeah, that's it.
Okay. Since Aijun didn't get the visa in time, I will present on behalf of him. So this is OSPF extension for the inter-area topology retrieval. So, okay, we have the background and extensions and the process. Here's the background of this draft. So basically the advantage of the SDN controller is it has a global view of the topology and the states in the network, and you can calculate the end-to-end path to assure the QoS and the performance requirement for applications. But when the network is divided into several areas and run OSPF as IGP, the detailed topology information will be hidden by the ABR routers. So the SDN controller would only gather the summary topology information from the routers running the BGP-RS at the locator, which is located in each area. And ISIS currently have the solution defined in this RFC, but there's no corresponding solution in the OSPF. So this is why the extension is proposed. So the proposal is for the fixed format OSPF messages, we need to reuse the rarely used field and redefine the associated fields to assure backward compatibility. And for the TLV format OSPF messages, we can define the new sub-TLVs to carry the prefix source router ID and include this sub-TLV in the corresponding OSPF v2 and version 3 LSAs. Then the BGPRS can report this information with the same object regardless of the IGP protocol used. This is the format of the fixed format LSAs. Basically, it is proposed to reuse the TOS field and the consequencing other fields to carry this new defined information. So when the number of the TOS is given one special value, you can use this other field to carry this source router ID information. This is the extension for the TLV format OSPF messages. The new sub-TLVs are defined to carry the prefix source router ID for IPv4 and IPv6 respectively. Oh, this is the process of how to retrieve the inter-area topology information. Basically, you need to collect the topology information via BGP-LS, and then you need the network summary and source router ID information gathered from this newly proposal. And then you need to combine these two information to identify the links between the different areas, so that you can build the multi-area topology in the end. So this is the, I think, IGN asking for the adoption of this draft, and it is asking for the order and comments.
I'll just go ahead. AC Lindum, there's some history here. We rejected a long time ago using those TOS, overloading the TOS and using it for others. So all the non-TLB based, I don't think we'd standardize that part if we adopt it. I mean, there was I think it was Padma had a proposal way back to reuse the TOS bits for other purposes, and we didn't do it then. We're surely not going to do it. And at that time, we did not have a way to extend OSPF v2 or OSPF v3, and now we have a way. So we surely wouldn't do those first two. Okay, we'd only do the TLV based.
Right. I mean, even if you were going to look at it, you wouldn't pick just one solution to use those bits, right?
Yeah. Hi, Ketan Talaulikar, Cisco. So we shared comments offline with the author, and you see that at least some of the non-backward compatibility changes have been addressed in this one. But as AC mentioned, the proposal to modify any existing format is simply not going to work and backward. But I would support the use of source router ID, TLV, and that's kind of equivalent to what is there in ISIS. So I think that's something that can be used for sure.
Yeah. This is AC speaking as working group member again. I think that you can look at the use case and say it's a little weak, but this could be used for other things too. We have it in ISIS. I think it makes sense to add it with the TLVs.
Okay, thank you.
It's Peter Pshenak, Cisco. So I agree, we can add the source router ID, but I still don't see how that fixes the problem that you are trying to solve. Because what you advertise is prefix, and you associated the router ID, the source router ID, with the prefix. But what you seems to try to do, if I understood it from the draft, you are trying to reconstruct the topology, but there's no topology data. It's just a prefix.
Yeah.
So I don't know how are you going to use this to reconstruct any topology data from it.
Yeah, I think maybe this question has to go to IGN you can send the question.
Sure,
Comment on
we'll
list.
take it.
Yeah.
Yeah,
I
sure.
think Here is how to use the topology and the prefix together to combine the multi-area information.
You're just using it as a locator, right? And then you're going to go
Yeah,
talk to
yeah.
that box to get the info using some other mechanism.
Okay, thank you.
Thanks.
I guess it is it Russ? I think it's Russ.
Yeah, I think so.
Oh,
Let's see here.
you actually want me to do something, is that it?
Yeah.
Oh, okay. I think they can do it. Right, cool. So you can flip to the next slide.
What?
Go ahead and flip to the next slide.
This should work.
Yeah.
It's, oh, it should, okay.
But it's scrolling. I don't know. What kind-
So it's just, you can't tell which one is full and which isn't.
Oh, okay.
So you just have to hit it twice. And
Okay, who knows? All right, Russ White, LinkedIn. This is just an update on Open Fabric. This was presented about a year ago. The drafts have been out there for a long time. Basically, just some review, just for people who haven't seen it before. Built the simplest possible distributed link state protocol, no policy, no configuration. We're trying to get to the point where we don't actually have configuration on the box, pretty much. And trying to keep out feature creep as much as we can. Changes since the last draft. There have been many minor changes based on a lot of different people's input, which is really appreciated, by the way. We have a lot of people who have given us feedback and ideas and things like that. The one major change is that the way the fabric location is calculated. There are many different algorithms possible. What we found is I've been working with Christian at NetDef on this a lot in working on an implementation, is that there are a lot of different ways you can do this, but most of them only work in one topology, one form of the CLO or spine and leaf. So we've come up with a solution that I think works in all different types of spine and leaf that we can think of. It basically just uses two routers manually marked as T0s or as top of racks, and then you just find the location based on a simplified SPF using hop counts from that. And by the way, we're using namings advertisement. So this is what I was talking about before. The mic is trying to get to a unified signaling. We're trying to rely on namings draft for signaling rather than building our own signaling as much as possible and working with naming and less on that stuff. There is two ways of optimizing flooding. I'm not going to go into detail again because this has been presented before. And if you want to talk more about it, I'm glad to do so in person or on list. But we're using RFC 7356 to do limited scope flooding kind of partially. There's a forward and a reverse optimization. I think AC had a question on the list about reverse. I'll talk to you about that later if you want to, AC, because I think it still works. But remove lots of stuff we don't need to or care about from ISIS. For instance, in this size of a fabric, we really don't need level 1 and level 2 flooding. We only need level 2. So we just actually, in the implementation, have taken level 2 processing or level 1 processing out as far as hellos and having multiple sets of LSDBs and stuff like that. There's some optimized neighbor formation stuff about the way you build adjacencies when you bring up an adjacency. Rather than going ahead and exchanging LSDBs, you check to see where you allow your first formed adjacency to fully form, and then you just do CSNPs to figure out what you need beyond that. Current state, there's an implementation in free-range routing. I say it's in progress. It's actually in acceptance test phase and scale test phase right now. We're going to do some functional and scale testing, and then we intend to push that, rebase it, and push that into free-range routing open source. So there will be an open source implementation out there. It's actually a compile time switch on the ISIS code that's already in free-range routing. I think we need a use case draft and/or use case appendix. We can talk about the requirements document that Chris was talking about earlier. I think we're going to need some Yang model modifications, and we'd like to see more implementations of this. And since AC said we're not accepting anything as working group items in this area right now, we'll just skip that request for the moment. And any questions, again, on list, off list, we're available if you want to chat about it, what we're working on, and where we go from here.
Yeah, I just want to clarify, I wasn't requesting a requirements document because I think that's a lot of times it's overkill.
Yeah, that's fine.
Just,
no, that's fine.
yeah.
That's fine. Yeah. I mean, we're mostly working on this because we feel like it meets some operational needs that we have on our fabric.
So AC Lindum, so this is just since this, I don't know, this almost seems like it might be a separate track because it diverges enough now from ISIS. I don't know. I don't know what we. I don't want to say experimental because it could be more serious than. Well, a lot of experimental protocols start out as experimental and then become very serious. So maybe that would be something to do and just continue. I don't want to dissuade you from changing things. The other comment I said, don't you need some discussion of the checksum?
Oh, Christian, we didn't think about checksum. We'll have to look at checksum.
Yeah,
All right,
okay.
good.
Because you're going to change,
Yeah, so that's two things we have to look at.
routers are going to change the flooding scope. That
Um,
other than the
But no, it shouldn't matter because the way this flooding scope is done, it shouldn't matter.
okay.
Yeah. It's done with 7256 extensions, which are basically
I
linked.
think the
over
PU
flooding.
type is not encompassed by the checksum, so you can actually change it.
Oh, okay, good,
Yeah,
good,
right, right, exactly. Okay. All right. So I'll quit, and if anybody has any comments or questions, bring them to the list. Or privately to me or Christian or whoever.
Also, I was thinking about something earlier with the flooding, with all this flooding stuff, is do we have anybody in, like the old interop labs at universities and stuff? I mean, it would be really nice if somebody was actually taking these different algorithms and comparing them and running them through scenarios and getting, maybe publishing papers.
Yeah, actually it would, Russ White, LinkedIn. One thing I'll say about OpenFabric that's interesting is this is actually modeled or uses the same algorithms or mechanisms used by the OSPF MANA work that was done many years ago. So it's actually, these algorithms are pretty much already deployed and running.
Right.
Many of them were much more complicated than this one, though.
Yes.
Okay, we got Wemo. Also, since his last presentation, anybody not sign the blue sheets?
Yeah, please do, especially if you're standing up and didn't get a chair.
Anybody?
You might want to sign twice. Vote early, vote often.
Hi, good morning, everyone. Today I'm going to talking about flooding reduction. So basically, I'll focus on the updates. So during the last IETF, we quite a few experts raised some issues regarding to flooding topology. For example, if some link down, some interface down, and then in this case, the flooding topology may be broken. So in this case, how do you provide or guarantee reliable flooding in the case some link down, some node down? So in this updates, we provide some solutions. So the second update is that in the 0.0 version, we talk about a different mode for computing flooding topologies. For example, we focus on distributed mode, which means that every node in the network will compute flooding topology and use their own flooding topologies. That's distributed mode. We also mentioned about centralized mode, which means that in one network, we select a leader. So that leader will compute the topology and then flooding the topology into the all network. And then each node in the other node will receive that topology and use that topology. In addition to that, we also talk about statically configured flooding topology. So in this case, on each node was in some way, operators can configure the flooding topology. And then each node in the network just use that static configured topology. So that's, we mentioned these three modes. So in this version, we provide support to like operator to select whatever mode they like. Also, so sometimes operator may, after selecting a mode, they may change to another mode. So in this case, we also provide a support to allow operators to smoothly switch from one mode to another mode. So first, we provide some solutions for reliably distributed or flooding the link state topology. So here we define a critical interface. So critical interface is an interface in the flooding topology. So when this interface is done, then the flooding topology will broken or split. So this interface, this kind of interface is a critical interface. So similarly, we can extend this definition to node, critical node, which means that when one node in the flooding topology is down, and then the flooding topology is broken or split, so that node is a critical node. So here we give an example for the flooding for the critical interface. For example, here the SIG line, green line, is a critical interface, because if this interface is down, we can see that the flooding topology will be split, broken. So in this case, I think the simple solution is that when critical interface is down, so we just use or return to the normal flooding, which means that every node in the network just flood to every interface. That's the traditional flooding. So that's the simple solution when critical interface is down or critical node is down. So in this case, we'll guarantee the link state will reliably flooded. So that's first simple solution. So in fact, this kind of solution is simple, but maybe use more resource. We can go down further to have some kind of optimized solution, which means that when critical interface is down or critical node is down, so we can compute backup path or some kind of backup flooding path. So those kind of backup flooding paths will be some way, those kind of backup paths or backup topology is a way to go through the other node to which connect those split topology. So as soon as we get those nodes, so the simple way is that each of those nodes on the backup stuff, we just flood to every interface. So in this way, we'll guarantee the flooding topology, the link state will reliably flooded. So if we can go further optimize, so we don't, for those nodes on the backup topology, we don't need to flood every interface. We just flood to some of the interface. So we can see that we have several levels of ways to provide guaranteed link state flooding. Simple way is that as soon as we have critical interface or critical node down, every node just return to the normal flooding. Very simple. So if we want some kind of optimize, and then we have a sum of nodes, each of those nodes will flood to every node, every link. Then that way we have some kind of optimized solution. Further, we can go to even optimized solution. Just those part of the nodes just flooded to some of the links. So secondly, we provide some support to allow operator to select select a mode. So here we provide so first we define operation. So operation means that operator can select whether we want a flood reduction. So operator can select this one very easily. So operator can just configure on any node in the network. For example, I want to enable flood reduction. So as long as operator configure that one on any one node, and then we can just flood this instruction to every node, and every node will enable the flood reduction. So in some case, after we have flood reduction, so maybe customer want to root back to normal flooding. So he just configure one interface, one node, just root back to normal flooding. So we provide some kind of operations, enable flooding, and then root back. So if a customer configure flood reduction, after that, the customer can select the flooding mode. So we provide a server mode. So we provide a customer can select centralized mode. So customer can also select distributed mode and a static mode. So for each mode, so we define the rules. So for example, if a customer configure centralized mode, and then we need the whole network need to select a leader and a backup leader, and then the leader will compute flooding topology and flood this flooding topology to every node in the network. And then every node in the network will receive the flooding topology from the leader and then use these flooding topologies. So for distributed mode, easy. Every node computes flooding topology and then use its own flooding topology. Also, our operator can indicate an algorithm for computing flooding topology, because we may define different or several algorithms, and then user can select one of them. So to guarantee every node will use the same algorithm to compute flooding topology. So this is a detail. So this is the extension for central mode, because for centralized mode, we need to select a leader. So in order to support this one, so each node in the network need to distribute some information. For example, the priority for become a leader, and then also after leader is selected or in the process of selection, so we need to define some kind of TLVs to indicate that the leader or backup leader is selected. Also, we need to have an algorithm to select the leader and the backup leaders. So in summary, and then we address the issues raised during the last IETF, and also we provide support to allow operator to select operation mode and switch from one mode to another mode smoothly. So I see this one is a general flooding reduction for any topologies. I think we would like to welcome comments.
Les Ginsburg, I feel like have two presentations that are saying exactly the same thing, in comparison to the earlier presentation that Peter made. So from a working group perspective, it doesn't make any sense to me to progress two documents that are doing the same thing.
Yeah, it was striking me as very similar as well.
Just AC Lindo speaking as a working group member, just intuitively, and it's not because I used to work for Tony and Peter's my friend, so don't take that into consideration. Yes, yeah. So, but intuitively, the first one is better because you're reverting to normal flooding at just the point where critical links are failing, when you're going to have more load on the network. So it's kind of, you're saving flooding when you don't need to, and then lots of changes come in the network if you revert to normal flooding.
So this one I mentioned that in that case we discussed different solutions. So one solution is we just return to normal flooding, as I talked about. So another solution is that we can find a backup of flooding topology. That means that part of the nodes link will be used to guarantee when one critical link or node is down, we use those backup link or nodes, some of the link, to guarantee we just back up those critical link downs. That's another solution. And even in the between, some of the nodes just do the normal flooding, but most of the nodes still use the flooding topology. There's different levels for optimization. That depends. We can discuss that in details.
Well, to Russ's point of having common signaling, right? I mean, and what Les was saying, we don't need two things to do the same thing. Maybe you could be working on the algorithms that were talked about, the distributed algorithms, or I mean, they really seem to be doing the same thing, though, right?
I think the signaling objective is the same. I think we just from beginning. So I think Tony Lee's algorithm is centralized in the first version.
Yeah.
And then my version is distributed.
Right.
But also in my first version, I talk about the distributed and the static configuration. But my focus is the distributed one. And Tony mentioned is a centralized one, right?
And then now they do distributed. Yeah.
Tony generalized his version to include the distributed one. And then because in my first version, I talk about the 3 modes. And then in this version, I think I address the issues raised by the experts, and also I generalize to cover more modes and more operations, right?
Maybe there's room for working together. I'm not sure.
Yeah, I agree. So if working together is okay because we tackle the same problem and a different approach, and then maybe combine together. I think, yeah, I agree.
Yeah, let's do that before we do another double presentation again. Okay. Do you have anything else to say?
No, I don't think so.
I mean, it just struck me, again, this is a naive comment. I got to reread this draft, but isn't static topology, isn't that mesh groups?
Static?
Isn't static configuration of flooding topologies mesh groups?
No, it's the starting configure is very simple. For example, for each.
Well, I'm saying we already have it, right? It's mesh groups.
We just mentioned that one. That's an example. For example, user can configure a node. This link is belong to one topology, and then we don't need to compute. That's another mode. Whether user need this one, we can discuss. I think, for example, for static routes or static something, for example, static speed, there's a way to provide to the customer. Some customer just want a static one. So just mention that one, maybe we can read more details.
Okay. All right, thanks.
Okay, thank you.
So it looks like we're wrapping a little early.
Yes, we are.
Any other comments? Okay, thanks everybody.
Yeah, the existing working document is really fast. That's what fixed it up.
Yeah. Well, I don't mind going early because honestly, I prefer to have, especially for the 2.5 hour session, I prefer to leave a half hour of slot.
Yes.
Because if you get into an interesting conversation and people are excited, I mean, to be honest, sometimes people just aren't active on the list. You get them in the room, they get excited about something, they start talking, and that could be when you hear something important, right? And Dino's not always going to be active on the list. Yeah.
I was subscribed to that when we were trying to do that geolocation.
Right.
And everybody told us to talk
Thank you.
I get the emails to our subjects. Right, yeah, so I can read out that next Sounds like a brother meeting. Yeah, I'm sure. I'm certain. Yeah, okay. Anything else? So I'll send you guys a meeting next week. Yeah, so you have right. So yeah, I'll send the meeting. I'll